Welcome everyone and thank you for joining. I'm Anusha. Today's session will focus on how modular architecture can be a catalyst for scaling agility, maintainability, and performance in enterprise platforms. We'll examine the core principles of modularity, compare implementation strategies, and look at real world applications and quantifiable outcomes, especially in service heavy domains. Let's understand modular architecture. Modular architecture decomposes large applications into discrete, self contained modules, each encompassing a specific business capability. These modules interact via stable interfaces, typically APIs or messaging brokers. Why this matters? It supports independent lifecycle management, build, deploy, and scale. It aligns development with domain boundaries, especially when using domain driven design (DDD). It simplifies testing and CI/CD pipelines by reducing blast radius of changes. Think of each module as a bounded context. It owns its own state, logic, and can evolve independently, making it a natural fit for cloud native systems. Let's break down the fundamental traits of a modular system, the core characteristics. First, encapsulation. Encapsulation prevents tight coupling by hiding internal implementation. For example, a customer module should expose only what's necessary, say a customer profile API, and hide how it aggregates loyalty points. High cohesion. All functionalities within a module should serve one purpose. A well designed order module should not handle customer notifications. Loose coupling. Modules communicate asynchronously or via stable contracts. This encourages event driven architectures, which decouple execution and increase fault tolerance. Interface stability. Interfaces, example, REST, GraphQL, or gRPC, must remain stable across versions. Tools, OpenAPI, or protobuf schemas are essential for maintaining version control and backward compatibility. Here's what to keep in mind when designing modular systems. First, separation of concerns. Divide responsibilities logically. UI, business logic, data persistence must be handled independently. For instance, don't mix billing logic into a product catalog module. Standardized interfaces. Use REST or gRPC with versioning and schema contracts. Employ tools Kong or API Gateway for managing and securing interfaces. Scalability by design. Each module can scale independently. Payments module can scale 3 times more than a relatively static health center module, saving cost and improving throughput. Usability. Shared libraries or common services. Example, auth, audit, logging should be extracted as reusable components or SDKs. Fault isolation. If the inventory service fails, the checkout should still proceed with estimated quantities or cache data. This is fault tolerance in action. Maintainability. Modularity allows you to migrate tech stacks infinitely. Example, you can refactor one module from PHP to Node.js without affecting the rest of the system. Let's look at the implementation paths. Microservices architecture. Each service has its own code base, DB, deployment pipeline, ideal for domains with strong service boundaries. Tools, Kubernetes, Istio, Docker, Spring Boot, etc. Modular monoliths. A single deployable unit, but internally organized as modules. Great for early stage teams or when deployment overhead needs to be minimized. Can evolve into microservices when maturity grows. Plugin architectures. Core system loads or injects new features at runtime. Common in CMS e-commerce engines with Magneto or data platforms Grafana. Enables feature toggles, A/B testing, and third-party integration. Use decision matrices based on deployment frequency, team size, service criticality to choose the appropriate architecture. Enterprise platforms benefit in measurable ways. Faster development. Modular CI/CD pipelines means teams can release independently. Less bottlenecks, fewer cross-team dependencies. Performance optimization. Light use enable caching, async processing, and targeted load balancing. Think of a high volume pricing service tuned independently from the backend. Simplified art in maintenance. Easier to isolate and debug issues. Telemetry tools Grafana and OpenTelemetry shine when your service emit consistent metrics. Technology agnosticism. One module could run Node.js while another run Python. Modularity enables polyglot services without sacrificing consistency. To illustrate the practical application of modular architecture principles, consider an enterprise e-commerce platform that successfully implemented a modular approach. Product catalog module migrated to a standalone service with Elasticsearch based indexing. This reduced query time by 47% and allowed for async ingestion pipelines. Customer management. Modularizing customer onboarding allowed targeted performance improvements, resulted in 40 to 60% reduction in form abandonment. Order processing adopted CQRS pattern to separate read-write operations, enabled 99.99% uptime with intelligent retries and circuit breakers. Analytics module introduced modular AI-based recommendation engine using a plug-and-play architecture, enabled 15% increase in product discovery through personalized runways. This shows how modularity enables both scalability and feature experimentation. Here are the benefits of modular approach. Faster time to market. Features ship faster with smaller, focused teams. Implementation speed. New capabilities can be added without disrupting existing ones. Resource utilization. Teams manage their own workloads and backlogs, increasing throughput. Team autonomy. Developers own modules end to end, leading to more accountability and innovation. This approach is key for scaling engineering orgs beyond a few cross-functional teams. It's not easy. These are the challenges and considerations. Initial complexity. Setting up module boundaries, defining contracts, and building pipelines take effort. Early investment is required. Next, performance overhead. Too many services talking to each other can increase latency. Use techniques bulkheads, caching, message batching, and connection pooling. Organizational alignment. Without clarity in ownership, teams can unintentionally couple modules. Establish clear domain ownership, supported by tools Backstage or Compass for visibility. Here are the best practices for adoption. Start with domain modeling. Use DDD to define module boundaries. Tools event storming or context max help here. Interface governance. Use API registries, schema validation, and contract testing. Example fact. Incremental migration. Don't big bang refactor. Extract one module, define KPIs, validate outcomes, then proceed. Feature toggles help. Automate everything. CI/CD, code quality checks, API linting, and runtime policies. This supports consistency and security at scale. To summarize, balance agility with stability. Modular architecture allows innovation without compromising system health. Supports sustainable evolution. Code bases, infra, and teams can evolve independently. Gain a competitive edge. Faster iteration cycles, lower risk, and greater developer productivity. Enterprise platforms is modular, composable, and scalable by default. Thank you for your attention. I would love to hear your questions, whether they are about module boundaries, migration tooling, or team structures. Feel free to connect with me.